All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are getting back to Kaggle. We are getting back to doing stuff on Kaggle, and I'm excited to make more progress in terms of data science. So, just some quick backstory. A couple months ago, or maybe I think it was a year ago, I'd gotten on Kaggle and I'd started doing data science stuff, and I was extremely excited because Kaggle provides you with um, they provide you with Kaggle notebooks. I was trying to figure out how to say that, but they basically let you create and host and even run Kaggle notebooks, which are essentially Jupyter notebooks. So like you can write code cells and also markdown cells because it's a Jupyter notebook. And then you can run them. And the best part is that Kaggle provides you with free compute resources as well. So the Kaggle notebook that you're running it on their servers. You're not running it locally. This is great because it makes it so people who don't have a whole lot of computer resources, a whole lot of hardware resources, basically people who don't have strong and capable enough computers, they would be able to do data science stuff and even machine learning or deep learning stuff, which is it's just amazing, dude. Like it was it was it was a blessing for me. It was amazing. I was super excited about it, and I used it for quite a while. And then recently being, I don't know, maybe 2 months ago or maybe a month ago, I can't remember at this point, but I moved my workflow over to the terminal side. And so the majority of the stuff that I was doing, it became terminal based. Even coding, I am doing it within NeoVim. So even that is now terminal based. And one of the challenges that I had there was that I had to find a way to move the workflow that I had from Kaggle over to the terminal side. And I managed to do that as well, thanks to NeoVim, Vim Slime, and Tmux. Thanks to these three tools, and a bunch of other tools that are working along with them as well. But thanks to these three tools, I was able to set up a multi-monitor setup, which is actually a multi-computer setup. It's not multiple monitors attached to one computer because I don't have that kind of powerful hardware that I can attach three monitors to one system. But I do have multiple old machines. And so because of tools like NeoVim, Vim Slime, and Tmux, I'm able to use these multiple machines for a multi-monitor setup. So I can write code on one screen. I can run it in an IPython REPL on another screen, and I can also display images if I need to on another screen. And all of this, including the displaying of images, it can be done within the terminal itself. The displaying of images is possible thanks to the Kitty terminal, which uses the Kitty graphics protocol. Kitty has its own graphics protocol. So thanks to that, I'm able to display images very easily. Now, recently, I got done setting all of this up, and the thought came in my mind that, hey, I remember reading about the Kaggle API. I never really took the time to dive into it because I was perfectly happy with um, writing my code in Kaggle Notebooks. But then now that I've moved my workflow, I was wondering if I can still use Kaggle's compute resources. Huge shout out to Kaggle, by the way. Kaggle is just it's a huge blessing for the data science and machine learning and AI community in general. Um, so back to what I was saying. I was wondering if I could still use Kaggle's compute resources for running my Python code. Like let's say if I wanted to train a model, would I be able to do that? And turns out, yes, it is possible through through the Kaggle CLI. I can use the Kaggle API to push my code to the Kaggle servers and then package it into a notebook and run that notebook, and then also receive the output or read the output from that notebook. So basically, the entire code that I'm typing out, that code gets bundled into one notebook cell, and then that one giant cell is going to run, and then that cell's output, I can read it. I can also read any files that get created. So that's a huge bonus as well. And I can also provide my own input files other than just the code file. So I've been working on setting that whole system up, and pretty soon we're gonna be getting back to doing data science stuff on Kaggle. And dude, I'm excited for that. I am really excited for that. Hell yeah, dude. I can't wait to get back to it. Now, speaking of Kaggle, something that I wanted to do is just a second. I need to make sure that this thing is still running. What happens if so I need to keep this thing open. Actually, let me just confirm that you guys are still able to see, even if I, oh shit, what happened there? It's not supposed to be in, okay, we can delete that. Yeah, I want to see if this shows up. So this is not showing up. Now, what if I do this? Okay, now it's showing up. So this cannot be minimized. This needs to be maximized. Um, right. So we're gonna get back to this thing. Now, what we are doing is the Kaggle Learn course, the Learn section, whatever you want. Basically, hold on. Basically, this, I believe, yeah, here. So they have this whole list of courses that can help you get from beginner to advanced in terms of not just coding, but also data science and ML. Give me a second. Right. So they have a bunch of these courses, and I recently found out that apparently they also provide certificates. They give you certificates for completing each of these courses, which is great. It's amazing. Like if you guys are looking for certificates to print out that say that, hey, so and so person has completed a course that gives them so and so knowledge, then this can be very helpful for you because they have courses in various different topics. So the courses that I have been, but I kind of want to go like, in order. Right now here, you're not going to see them in order because right here where it says your courses, these are courses that I decided to jump into, even though they're not exactly like the beginner stuff. I didn't realize that it was counting the completion thing. It was adding to the progress bar as I kept scrolling down in each of the courses, but then it kept adding here. And because I had opened up multiple separate courses from this list of courses, so they went out from this list and now they are kind of divided here into your courses, which is basically courses that I started but I didn't finish, and these courses which I didn't start. So, out of this, I have finished one course, which was Intro to Programming, and now I'm currently doing the Python course. And I'm mainly just doing this for the sake of doing it because I I mean, I have like a decade's worth of experience in Python, so obviously I don't need to learn the basics of Python. But for the sake of completing it, I want to do this. That's why I've been spending time going through this. After this, the next one, I think the next one is pandas. Let me just make sure. I'm not entirely sure. Uh Preparation for intro to machine learning, pandas, intro to SQL, intro to so and so, so and so. Okay. Yeah, you know what? I think that might be it. Though I mean I can very easily just open up the Kaggle Learn page on in like a private browser tab where I'm not logged in, and there I can look at the course list and find out what what was I saying? Yeah, there I can find out. There I'll basically see the entire course list in order, in chronological order, and then I can decide which one I want to go for next. But I believe pandas might be the next one, and after that it might be intro to machine learning or data cleaning. I'm not sure. Yeah, yeah. We'll go through all of them. So I'm currently in Python, and I've been going through this Booleans and conditionals chapter. So I'm done with the theory part. I'm just going through the exercise so that it counts towards, me completing this thing. Let me just make this screen a little bigger, give us a little more real estate. I'm not sure if that's working. Okay, that's fine. That's okay. But dude, I'm excited. I am very excited. Oh, don't do that. Don't. Okay. Sorry. I had TikTok open and there was a video playing and I didn't want that music to get played. Okay, so let's mute this and open up my chat real quick. Okay, cool. Let's see how the video looks. Great. Awesome. Cool. Okay. So, that being said, let's continue. I think maybe the next couple of days or something, I might just go through this. Now, my plan is not to use Kaggle Notebooks. My plan, in terms of doing stuff on Kaggle, is to use my terminal based workflow and use the Kaggle CLI to push code to Kaggle to run it and then get back the results. So if I'm doing something that's compute intensive or CPU intensive or something that might even require a GPU, I can then push that code to Kaggle, let whatever the task is complete, and then I can retrieve the results. I'd imagine if I wanted to, let's say, visualize massive data sets, because that's another thing that I want to do. I want to get back to the idea that I had previously, where I would perform exploratory data analysis on random data sets, and then I would create these notebooks that kind of present the exploration. Now, this part is going to be a little bit complicated because what I'm going to have to do, because I'm not using notebooks anymore. However, there are tools that allow you to write a Python script in a specific format, which you can then pass into a tool. I forgot what the tool's name is, but you can pass it into that tool, and then that tool is going to process the entire thing and divide up your code and text and all of that into markdown cells and code cells, and it'll basically give out a Jupyter notebook for you. So you can then push that Jupyter notebook to Kaggle, and on Kaggle, it can be viewed pretty easily. So these are two approaches that I want to take. One is to just use the script workflow, because apparently you can do both of these things. You can you can have a notebook that's basically a script, and you can also have a notebook that's actually a notebook. Uh, You can do both of these things. I found that out recently. And you can do that thanks to the Kaggle CLI. I don't know if it's possible to do that um, through the web UI, but when you're doing it through the CLI, then you can specify whether you want to do a notebook or a script. To be fair, I got this information from Gemini. I haven't yet tested that out. So if that turns out to be wrong information, then my bad. I still have to look deeper into it. That's actually why I didn't stream yesterday, because I decided to take take the time to set up that whole workflow. And dude, I feel like once I have this set up, there's gonna be quite a bit that I can do. I can do exploratory data analysis. I can do my AI research. I can do, like, if I'm trying to build um, if I'm trying to build custom models for something, I can do that as well. And I can leverage Kaggle's resources to kind of help my work. Like, even if I don't have the compute resources that are required for example, training, I can use Kaggle's resources instead. They give you they give you an unlimited amount of well, how do I say this? They give you a certain amount of CPU resources, but they give you like an unlimited amount of that. They also give you RAM, which is that was a pretty big amount as well. I don't remember how much. Wait, I think there's a. Is this running? This is not currently running. Let me run this. Hold on. Things are going to be a tiny bit slow. Just a second. Okay, what was I saying? Yeah, so I need to run this. I'm just gonna run this thing and take a look at the resources, because I want to show you guys that we do get resources from Kaggle. I don't know if the amount of resources that we are getting changes if we are running the Kaggle notebook through the Kaggle CLI. I'd imagine we still get the same amount. But yeah, at the very least, you get CPU, a good amount of CPU, a good amount of RAM, and a decent amount of space. Oh, hold on. I think I need to run the entire thing from the beginning, because um, I left this for a while. Okay, so this is our session. So this shows CPU. Okay, this doesn't mention uh, I forgot what was going on here, but you have 30 GB of RAM and around 60 GB of hard disk space. And there's also a decent amount of CPU. This isn't it though. Like, this isn't the only thing that you get. You also get a certain amount of free GPU resources and free TPU resources. I haven't used the TPU part yet. I might touch that at some point in the future, but GPU is definitely what I'm very heavily leaning on. And they give you like 30 hours of GPU runtime per week. So every week that quota resets. Like, this is amazing. If you guys are looking to get into data science, then definitely, I mean, data science or ML in general, and you're still learning and you don't have compute resources, definitely use Kaggle. I would also advise that, you contribute something to Kaggle as well, but like, I'm not going to be one of those people who shames you for not contributing anything and just using Kaggle resources, because the resources are there, right? Use them. They're there for you to use. Even if you're not contributing anything to the Kaggle community, these resources are there for beginners and even advanced people to use. Now, that being said, let's run this, and I think that's done running, right? And then I also finished this. Yep, that says correct. And then I also finished this. I did not finish this. Did I? Wait, did I finish this? Uh, okay, we decided to, oh yeah, okay. So the actual exercise is here, and here I did finish it. Yeah. Then there was this one, which it started to get a little confusing for me, because this was one of those things where it was kind of like, okay, I was seeing and or. This is basically like a Boolean expression. It's like a conditional expression. There's multiple conditions chained in there, and I was seeing or and I was like, hold on, I'm not seeing any parentheses here. So like, how exactly is it doing the grouping? Is there like some precedence, the way there's arithmetic precedence? So it was getting confusing, and I didn't want to spend too much time doing this. So I just looked at the solution, which is here. So that's done. And then we were in this area, I believe. Right. So this says the function is negative below is implemented correctly. It returns true if the given number is negative and false otherwise. Wait, it returns true if the given number is negative and false otherwise. Okay, okay. However, it's more verbose than it needs to be. We can actually reduce the number of lines of code in this function by 75% while keeping the same behavior. See if you can come up with an equivalent body that uses just one line of code and put it in the function concise is negative. Hint, you don't even need Python's ternary syntax. Okay, all right. So if it is negative, so basically if it is, yeah. So um, return true if number is less than 0, else false. That should be it, right? Yeah, that's correct. Great. So we can move on to the next one. 5a, the Boolean variable ketchup, mustard, and variables. Okay, the Boolean variables ketchup, mustard, and onion represent whether a customer wants a particular topping on their hot dog. Okay. We want to implement a number of Boolean functions that correspond to some yes or no questions about the customer's order. For example, onion less, return whether the customer doesn't want onions, um, wants all toppings, return whether the customer wants the works, which is all three toppings. Wait, so what are you asking me to do here? No, what's the exercise here? Wants all toppings, and then there's onion less. Okay, hold on. The Boolean variable so and so so and so. We want to implement a number of Boolean functions that correspond to some yes or no questions about the customer's order. For example, so and so and so. Wants all toppings. Wants all toppings. I don't get it. So what is this supposed to return? Um, like a tuple of true values? When you've updated the starter code, check will tell you whether the starter code. Okay, so am I not supposed to update this? Okay, all right. Let's take a look at hint because I'm kind of confused. You'll need to use the AND operator. Okay, so these are booleans, right? Okay, so return ketchup and mustard and onion. Is that what you're looking for? Correct. Okay. All right, dude. Um, okay. Great. Moving on. Thank you for the hint. So 5b. For the next function, fill in the body to match the English description in the doc string. Wants plain hot dog. Return whether the customer wants a plain hot dog with no toppings. Return whether. Okay, so what we are doing here is passing in the ingredients and okay, let's try this. I don't know if this is going to work because I've rarely ever had to do this. The only time I had to do Boolean stuff like this was when I was doing pandas and NumPy stuff, data frame stuff, and that was for like a specific data science project where I needed to kind of combine the results of multiple filters to decide whether to keep a certain filter in the equation or ignore that filter in the equation. Give me a second. Okay. All right. So, I forgot what I was saying, but yeah, let's see if this works. I've never had to do this, so I don't know if this is really gonna work, but apparently it is correct. Okay. Oh, I didn't realize that this could work as well. Okay. All right. We can also factor out the knots. Yeah, I've never had to think of it in this way, but good to know. Good to know. All right, we know what to do. No, you know what to do. For the next function, fill in the body to match the English description in the doc string. Return whether the customer wants ketchup or mustard, but not both. You may be familiar with this operation under the name exclusive or. Okay, that's interesting. So it's either or. So, okay, I'm just gonna try something here. ketchup, um, where's the fucking operator, dude? There. Ketchup or mustard. This was literally a shot in the dark. Again, something that I've rarely ever had to do with just Booleans, but like with other stuff. I've had to do this with, I've had to do this kind of a Boolean operation with other binary numbers, but rarely ever had to do it with this. Or I guess you can say that whenever I had this kind of a situation, I didn't really handle it in this way. I handle it in a slightly more verbose way. And this is coming from a person who has like a decade's worth of Python coding experience. Imagine that. Okay, cool. So we are done with that. Then we've seen that calling bool on an integer returns false if it's equal to 0 and true otherwise. Calling bool on an integer returns false if it's equal to 0. That makes sense. Otherwise, it returns true. What happens if we call int on a bool? That should just be 0 or 1, right? Or will the false be -1? I think that would be interesting to look at. Hold on. Try it out in the notebook cell below. Can you take advantage of this to write a succinct function that corresponds to the English sentence, does the customer want exactly one topping? Oh, okay. Hold on. Um, how much more do we have of this? Okay. Exactly one topping. Return whether the customer wants exactly one of the 3 toppings on their hot dog. Okay, let's test some things out here. So let's say A equals true, B equals false, and then let's do int A. Okay, and then that is 0. Oh, it's 0. So wouldn't it then be okay? Let's try this. Let's try this out and see. Int ketchup, because these are all booleans, right? Int ketchup plus int mustard. Actually, can't I put the entire thing into one? Though, wait, can I actually do that? Wait, um, int a plus b. Does that work? Okay, can I just do this? Does that work? So if we give it an arithmetic operator, then it implicitly converts the thing to int. That being said, we can probably do something like ketchup plus mustard plus onion and wrap that whole thing up into this equals 1. So that should get it done, right? Yeah, it does. Okay. So this was my initial thing that I was planning on doing, and then this is what I ended up doing later on. Um, Yay me. Awesome. Okay, cool. Wait, no. Did they give some extra information? The condition would be pretty complicated to express using just so and so, but using Boolean to integer conversion gives us this short solution. Fun fact, we don't technically need to call int on the argument. Yeah, okay, that's what we were testing. Just by doing additions with booleans, Python implicitly does the integer conversion. So we could also write so and so. I was thinking about this um, the other day. I was like, okay, I'm going deeper into Rust, right? I'm trying to do as many things as I can in Rust, but like I don't really want to completely abandon Python. I don't want to step away from Python at all, for that matter. Like, I kind of want to have both of these languages under my belt, and I kind of want to make both of them my daily drivers. The way at one point in time, the way how at one point in time I had C Sharp and Python as my daily drivers. Now I want to have Rust and Python as my daily drivers because there's quite a bit that you can do with Rust. There's quite a bit that you can do with Python as well. Python is one of those languages that it is so concise that it gives you the ability to prototype very quickly. And there's so many things that you can set up very quickly with a very small amount of code. And that exact same thing, trying to do it in Rust is going to be it's going to be a nightmare to type out because there's just so much to type out. The language is very verbose, and it's for good reason. Like, I'm not complaining about it, but at the same time, it kind of seems like I can get shit done very quickly with Python. But if I need performance, then I should lean on Rust. That is why I think I mentioned this in a previous stream as well. I've been kind of wrestling with the idea of doing my entire stream AI voice app in Rust, like the entire thing. Um, the little chat client that's going to run on a separate machine, that's going to be in Rust, and the main application that's going to receive the text, that's going to be in Rust as well. The main application that receives the text and then dispatches the text to worker threads to um, convert into audio. So to basically dispatch the text to the STT models, the speech to text models. To in this case, actually not speech to text, text to speech. So there was going to be that main app that receives the text and then dispatches it to the Kokoro TTS models, right? I was going to do the main app in Python, and then the worker threads, the distributed worker threads, were all going to be in Rust. But then now I'm wondering if I should just do the entire thing in Rust because why not? Like, why even involve Python in that when I can completely just not have Python involved? Because like even the Kokoro TTS model, I'm able to set that up using Onyx, so I can export that to the Onyx format. And once I've exported it to the Onyx format, I can run it on basically any platform that supports the Onyx runtime. And Rust has its own implementation of the Onyx runtime. So I 100% have the option to do that. And an added bonus with Rust is going to be that I'm going to be able to do multi-threading much, much more easily than I would on the Python side. And I mean like true multi-threading. On the Python side, to achieve true multi-threading, I would have to use multiple processes. But in this case, I will just be able to do true multi-threading. And also, I'll be able to um, do distributed multi-threading. I'm calling it distributed multi-threading, but basically, I'll be able to combine the multi-threaded version of the app that I was planning on making, and the distributed version of the app that I was planning on making. I'll be able to combine both of them into one, and allow the user to kind of customize how that works. Yeah, dude, I have some plans for this, and I feel like now the direction in which my research has been going in terms of both Rust and Python and deep learning, because of this, I kind of feel like I'm ready to take on that challenge to do this kind of an application in Rust. Okay, anyways, so we are done with that. Let's take a look at this. Yeah, there's two more of these remaining, and then we'll be done with this as well, and we can then move on. Okay, so in this problem, we'll be working with a simplified version of blackjack. Blackjack? What? Blackjack. We'll be working with a simplified version of blackjack, aka 21. I didn't know the game was called 21 at some point. Anyways, in this version, there's one player who you'll control and a dealer. Play proceeds as follows. The player is dealt two face-up cards. Um, the dealer is dealt one face-up card. Okay. The player must ask to be dealt another card, which is hit, as many times as they wish. If the sum of their cards exceeds 21, okay, yeah, that's typical blackjack rules. Though there is also a rule that you are not allowed to. Yeah, okay, I think that's coming up later on. You're not allowed to hit past a certain number. But okay, if the sum of their cards exceeds 21, they lose the round immediately. The dealer then deals additional cards to himself until either the sum of the dealer's cards exceeds 21, in which case the player wins the round, or the sum of the dealer's cards is greater than or equal to 17. Wait, what? Until the sum of the dealer's cards. Okay, what about the player? If the player's total is greater than the dealer's, the player wins. Otherwise, the dealer wins, even in the case of a tie. When calculating the sum of cards, Jack, Queen, and King counts as 10. Aces can count as 1 or 11 when referring to a player's total above. We mean the largest total that can be made without exceeding 21. So example, a plus 8. Okay, yeah. For example, a plus 8 equals 19, or a plus 8 plus 8 equals 17. Yeah, yeah. So you can choose between it being 1 or it being 11. All right. For this problem, you'll write a function representing the player's decision-making strategy in this game. For this problem, you'll write a function representing the player's decision-making strategy in this game. We've provided a very unintelligent implementation below. Okay. Oh, this is your unintelligent implementation, basically just saying no, don't hit. This very conservative agent always sticks with the hand of two cards that they're dealt. We'll be simulating games between your player agent and our own dealer agent, by calling your function. Try running the function below to see an example of a simulated game. Oh, I'm not supposed to change this? Okay, hold on. Um, Return true. Wait, am I supposed to change this function? You'll write a function representing so and so. Is this supposed to be the function that I change? Because this just says false, but then the description here says something else. It says return true if the player should hit, which means request another card, given the current game state, or false if the player should stay. When calculating a hand's total value, though, okay, at what point do they stop the player? Because from what I remember, when the player crosses this value, then the player is not allowed to hit anymore. But like, do I have that wrong? I think maybe I have that wrong. Maybe they just, because now that I think about it, allowing the player to continue hitting, it's just a it just increases the risk for the player. So if the player wants to take that risk, then they can. But if but like with the dealer, I guess they stop at 17. The sum of the dealer's cards, wait, the dealer then deals additional cards to himself until the sum of the dealer's cards exceeds 21, in which case so and so, or the sum of the dealer's cards is greater than or equal to 17. If the player's total is greater than the dealer. Okay, so I think I never learned this part of the rules. I don't know if the rules that I was taught back then were incomplete or if this rule was added later. I'm leaning more towards the fact that the rules that I was taught were incomplete, or maybe I just didn't understand the rules at the time. So this specific rule I need to keep in mind. Obviously, if the dealer crosses 21, they lose, and the dealer stops dealing themselves cards their um, if their if the sum of the dealer's cards is greater than or equal to 17. So at that point, if the player's total is greater than the dealer's, then the player wins. Oh, that's the cutoff point. That's the cutoff point. That's how they decide that, okay, this is where we stop and we check the score. Okay, otherwise the dealer wins, even in the case of a tie. Okay, all right. So when calculating a hand's total, we count aces as high with a value of 11 if doing so doesn't bring the total above 21. Otherwise, we count them as low with a value of 1. Okay. For example, if the player's hand is ace, 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 7, we will count it as 11 plus 1 plus 1 plus 7. And therefore, set player underscore total equals 20, and player low ace is 2, player high ace is 1. All right, okay. This very conservative agent always sticks with the hand of two cards that they're dealt. We'll be simulating games between your player agent and our own dealer agent by calling your function. Try running the function below to see an example of a simulated game. Okay, let's try that. Remember, you must first create the following variable. Okay. So I haven't really written the function. Okay, the real test of your agent's mettle is their average win rate over many games. Try calling the function above to simulate 5,000, no, the function below to simulate 5,000 games, no, 50,000 games of blackjack. It may take a couple of seconds. But that function just says false. It doesn't. Okay, our dumb agent that completely ignores the game state still manages to win shockingly often. Yeah, because you you never hit, like it's always false. Try adding some more smarts to the should hit function and see how it affects the results. Okay, let's go based off of the logic that they were describing. So dealer total Okay, dealer total is okay, and then player total, and then player low aces, and player high aces. Okay, so we are not deciding. So player low aces counts as one, and high aces counts as okay. So what are we trying to do here? So we have the dealer's total, we have the player's total, right? We want, wait, we have the dealer's total and we have the player's total. And we want, oh, we also have the number of low aces and high aces that the player has. This is the number of low aces and high aces. But then how is the player total being decided? Like these are, so okay, the player total has already been decided, right? No, because it's passing in player total. Like that's what's confusing here, that it's passing in player total. It, passing in dealer total is fine, but here it's passing in player total and then player low aces. So have the low and high aces not been counted in player total yet? Let me read this thing again. When calculating a hand's total value, we count aces as high if doing so doesn't bring the total above. Yeah, that makes sense. Otherwise, we count them as low. For example, if the player's hand is so and so, we will count. We will. Hold on. Let's take a look at the values that are being. Yeah, this is it's the same thing, right, as previous. So let's print out. No, hold on. This is gonna happen 50,000 times. Simulate 50,000 times. Oh, this is happening only once. Okay, all right. Let's print out. Actually, no, hold on. Player starts with 3 and 6. Dealer starts with ace. Okay, let's uh, let's start printing things out. Okay, dealer total, player total, then player low aces, and then player high aces. So let's run that, and it's okay if it's returning false. Let's run this again. It did not. Yeah, it is not using. What if I do it here? Oh, stop, stop, stop. Holy shit. This is doing it 50,000 times. Wait, stop, 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 stop. Okay, is it done? Nope, it's still going. Yep, that is my fault. So we're gonna wait for this run to finish so that we can clear out the cell output and then restart. Uh, are we done yet? I don't know. I think it's still running. Yeah, I think it's still running. I think it might be still running. I'm not sure. Okay, it's still saying cancel run here, so I don't know. But okay. So we are trying to give this some intelligent some thinking capabilities. You know, I could easily move on to the next chapter, but like I kind of want to challenge myself a little bit here. What's next? Lists. And then we have loops. And yeah, we are going through. All right. Okay. Cool. Right. Oh, good. Okay. The run is completed. Finally. Okay, return true if the player should hit, um, given the current game state, or return false if the player should stay. Right. Now, okay, let's say, so currently this is always returning false, right? Let's say, so we have the dealer total, we have the player total. Okay, start with the res false. Okay, that's our default. If player total is greater than 17, res equals false. And then we return res. Let's try running this and see. Okay, I think that's slightly increased or decreased the win rate. Okay, right. Um, so let's say it is. Oh, you know what? We could make this a little concise. So res equals uh, player total greater than 17. Okay, let's just make sure that works so far. That works. Okay. All right. Res equals player low aces. So if we have 17, actually, we should also be counting the number of high aces, right? Um, hold on. So, what's a good strategy to follow here? I'm trying to think. Wait, give me a second. Okay, yeah. So what would be a good strategy to follow here? So, okay, let's say, okay, if player total is greater than, or actually, let's say less than 14, or let's say less than 10, then if there's only one higher ace, player, what is it called? Player underscore high aces. Uh, if equals 1, then res equals true. No, I feel like this is not a good way to, because like we would be using, I kind of feel like we should have a sort of confidence score where, okay, so let's have a confidence score. Let's say conf, just conf is fine. Confidence score equals 0. If player score, actually we already have the dealer's total, right? Let's set it here to where conf greater than 10. So if the confidence is greater than 10, then we hit. If it's not, then we don't. Okay, and what we can do here is, So if player score is, I'm kind of confused about like whether the lower aces and higher aces are contributing to the player total. Is it player score or player total? Player total. Uh, for example, if the player's hand is at so and so, we will count we will count it as okay. Let's do low score equals ace low score. No, let's do ace low total equals player low aces multiplied by 1. Well, I mean that doesn't really, yeah, that's just unnecessary then. But here we need player high, aces high total equals player high aces multiplied by 11. So that's then going to be our score there. Okay, for the sake of uniformity, let's do this. Player high, no, player low aces. Aces low, okay. Aces high, okay. Wait, no, I'm still kind of confused with this because are we being told that hey, this is, wait, back up. Let's do something here. Um, let's do that and then do that. Wait, wasn't there another thing here? There was something to simulate one game. Yeah. Okay. Let's bring that here and do that. And right. Player starts with K and K. Total equals 20. Player's turn. There's our scores. So there's no aces in there. Okay, dealer's score is 6. Player's score is 20. There's no aces, so the total is 20, and the player should not hit. Um, Dealer busts, player wins. All right, let's simulate another game. Okay, let's simulate another game, another game, another game. This is not, we are not getting aces. What's going on? I want to get aces, dude. Okay, all right. So the total score is, the player has already decided what they want to count as a high ace and what they want to count as a low ace. All right. So the score that we are looking at is already chosen. Like it's already okay. All right. Let's try this. So we probably, okay, we might still need, actually we don't need this because we don't have to calculate the score ourselves. So if player total is less than 14, then confidence, I don't remember if this works in Python. Is this a thing in Python? Hold on. A equals 1, A plus equals 1, A. Yeah, I can't remember if this is a thing in Python. Okay, that works. Great. Uh, right. So then we increase our confidence score. Actually, if the player total is less than 10, then we increase the confidence score by 5. Else if player total is, I'm hoping that it's only going to catch one of the conditions and then just stop. But yeah, if it's less than 15, then our confidence score would be 2, because it's still risky. Else, um, oh yeah, actually past that point, we should probably not risk it. Oh, you know what? In that case, what we could do is, if it is greater than 8, then we have a confidence score of 5. If it is greater than, let's say, 13, then we have 2. And if it is greater than 16, then we have a confidence score of 1. Okay, then if dealer total is less than, let's say, wait, this is our one hit, right? We are not counting more. So then if the dealer total is less than, wait, the dealer is going to hit after us, right? If the dealer total is less than 17, then there's a chance that the dealer is going to hit. Actually, if it's greater than 17, then our confidence would increase by, let's say, 3. Else if dealer total, wait, I think I did this wrong. So if it's, actually, we could do 8 here as well. So if the dealer total is that, okay, and then 13. Actually, we could, yeah, maybe we could try applying the same numbers here as well. Else if player total is greater than 16, then conf plus equals 1. Not player total, dealer total. All right. If, I don't know, I don't know if the aces are supposed to like count, if they're supposed to contribute towards something, but like I'm gonna add it anyways for the sake of having a score. Um, player ace, what was it? Player low aces and high aces. If player low aces is greater than, you know what? Yeah, conf confidence plus equals player, what was it? Low aces, and then confidence plus equals player high aces. We're gonna run this. All right, we didn't bust. Player wins. Okay. You know what? We're gonna test this. We're gonna test this out. So at this point, I might just need to tune the confidence threshold and then see if, oh, that reduced the win rate. Okay, let's reduce the confidence. That reduced it even more. Let's increase the confidence. Okay, let's take it to 12. No, actually, 11. Okay, let's tune this a little bit. So if the dealer's score is more than 8, then there's a chance that the dealer will, you know what, maybe we shouldn't. I'm trying to think of this like in terms of stats. Okay, what if we remove this and take this down here? Okay, run again. Right, let's get rid of this. Okay, instead we'll say if the dealer's total is greater than 17 already. Actually, no, we should be looking at less than 17. No, you know what? So if dealer total is less than 8, we increase our confidence. If it's less than 13, we increase the confidence by that much and then by that much. Let's try this. I feel like this made us way more. This made us way. Hold on. So what happened here? Total was 8. I said if it's greater than 8, so we just did not. Player stays. Yeah, okay, we just did not hit. So I need to tune my values. So let's say greater than 5. Okay, and then we can add another thing here, else if player total greater than, let's say, 9. Then confidence would be equal to that. Okay, player stays, player wins. Player wins because dealer busts. Okay. Nah, the It was that one game that we did well in. Overall, we are not able to do that well. I wonder what the reason is that we are not doing well. Is it because we bust, or is it because... Okay, hold on. Let's try something here. Okay, let's run this over 50 and see the total score. Okay, player total is 20. Okay. Yeah, so then we don't hit, do we? I wonder if I need to maybe move this up and then have the player down. So first we look at the dealers thing, then we look at this. Okay, let's say if player total is greater than 18, then confidence equals 0. Okay, so this will prevent us from busting. Let's increase to 50,000 and run that. Okay, let's change the score. What if I increase the score? See, I'm trying to hit at least 40,000. Oh, not 40,000. 40% in terms of win rate. What if we do 50%? No, not 50%. 15 score, 16. 15 seems to be good. Okay, what if we do this? So here we might run into an issue where the confidence never goes down. Okay, 38. Okay, how do we increase this? Okay, you know what? As fun as this is, I'm done with the chapter, so I think I'll move on from this. Um, I think we are good in terms of, like, it should count, right? If I refresh, if I refresh this page, this thing should show up as completed. Give it a second to refresh. No, that did not count for some reason. Did I miss something? It says 7 is optional. This is correct. Okay. This is correct. This is correct. That is correct. Okay. I don't know. Was I supposed to run that code cell? I'm not sure. I could try something. I could just run through all the code cells. Um, and then hopefully that'll count. Yeah, no, that didn't count yet. So let's do one thing. Let's run all the code cells. Wait, I can't tell if it's done. I'm not sure if it's done. Okay, now let's refresh this and see. Yeah, it's still saying, why is that? What did I miss? Okay, let's go from the beginning. So we do the setup. Great. Then we do this. Wait, I wonder if that was the issue. Let me try refreshing. No, I don't think that was the issue. Okay, let's run this as well. And then run this as well. And this. Run this code cell to receive credit. Okay. Does it say that for any of the others? I don't think it said that for any of the others. Yeah, I don't think so. Okay, so we ran that. To get credit for completing this question, your code should return a correct result. Wait, did I not solve this? I think I did solve it. Oh, I didn't solve it. Okay, that was the issue. Okay, let's just copy this. That's okay. What we are trying to express would be more like this. The key problem is that Wait, I wasn't supposed to change this. I was supposed to give the parameters. Um, so this is what I need to change, not the other thing. Wait, false, zero, false, false. Okay, let's do that. False, zero, false, false. Okay, great. We are done with this. So now we can move on to lists and start that tutorial. So if I refresh this now, we should see, yep, that is completed. Great, awesome. Give it a second, let it finish loading. I'm wondering if I should do this on stream or off stream. Yeah, just give it a second. See, this is actually another reason why I want to do this. Why I want to do the Kaggle stuff through NeoVim instead of doing it through Kaggle Notebooks. It's because sometimes things end up being slow. And let me be clear, it's not because of Kaggle, it's because of my machine. The machine on which I'm currently doing stuff, it is incredibly slow to do stuff even through the browser, which is what I'm using Kaggle through right now. Even doing browser stuff on this machine is pretty slow. But well, I mean, I could do the Kaggle stuff from another machine, from one of my Linux machines. It's just not going to be as convenient. However, using the Kaggle API, it would become more convenient. So I'm definitely going to be giving that a try. And on the bright side, because I'm going through all of these courses, I don't know if it shows. Yeah, in Learn, it shows the entire thing. So after Learn, I don't remember exactly what um, comes after Learn. Okay, so we have intro to programming, then Python, then intro to machine learning. So it jumps to machine learning. From there, then it moves to pandas. I'm assuming in machine learning, it's gonna introduce us to scikit-learn, and then from what I remember, there was a thing where we it introduced us to not linear regression, but decision tree regression. It was linear regression using decision trees instead of I forgot instead of what. It wasn't just linear regression. It was linear regression, but using decision trees. So it was decision tree regression. I don't remember. We'll go over that as well. I'm not done with that chapter. After that, we have pandas, and then we have intermediate machine learning. Then we have data visualization. So all of these interesting things are coming up. Oh, is that done loading? Hopefully it's done loading. Yeah, right. Lists in Python. Lists in Python represent ordered sequences of values. Okay, cool, cool. I don't think I need to read this entire thing. I also don't think I need to, like, can I collapse this? Yeah, great. So we have some more space. Okay, right. Lists, lists, lists. We can even make a list of lists. Great. There's a trailing comma. Uh, okay, this is something that I tend to forget. It's that lists can have mixed types. You're not limited to just one type. I tend to forget that. All right, okay. Indexing, right, right, great, okay. Slicing, okay, cool. Changing lists. Oh, like adding and removing? Okay. Sorry, zoned out. Okay, list functions. Yeah, okay, cool, great, awesome. List methods, yep, yep. Searching lists, okay, okay, okay. Then we have tuples, all right. Okay, let's start the exercise. Yeah, give this a second as well. Man, this is really taking its time. Holy shit. This is really taking its own time. My God, dude. Should I refresh? I'm pretty sure this is because of my own machine, not because of Kaggle. Let me try refreshing it. And in the meantime, let's go open up that what was the next one? Intro to machine learning, I believe. Yeah, I'm already like halfway through this, but I'm still gonna go through it again. Yeah, it says model validation. That's the next exercise because I'm already halfway through this thing. We're gonna go through the entire thing again just because this is a good learning opportunity. I remember the first time that I went through it, I didn't really fully understand everything that I was doing and everything that was being taught because I was still pretty new. Okay, dude, I think it's been like a good 5 minutes and it's taking its own time. I would love to continue doing this, but like if this shit is going to take its own time, then I might as well just do it off stream. Because it's going to be a little less slow if it's off stream. So, that being said, here's what I'm going to do. Okay. Um, I think I remember this person. Yes, this is a person named Bayfinger and Baljeet. We have rated this person in the past. We're gonna go hang out in their stream. Yeah, this shit is taking its own time to load. I mean, Kaggle, it's taking its own time to load. So, yeah, I think I'm just gonna end here. And whenever this does decide to load, I'm pretty sure it's some issue with my machine. I might need to restart my machine, and then things might go a little more smoother. But yeah, I'm gonna carry on doing this off stream, and hopefully I'll finish the entire Python track before the next stream. And in the next stream, we can then do the intro to machine learning thing. And yeah, what I want to do is at some point, as I'm learning these things, as I have the exercise open in one page, I want to be able to practice the exact same thing in NeoVim, and then have the results be shown, or have then write out the same code in the notebook to complete the exercise, if that makes sense, because I kind of like that approach of learning a little better. And I feel like it's going to be a little more better for me performance wise. Um, but yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.